And thanks everyone for joining. Again, my name's Chris Janson. Some of you folks on here may have either seen or heard from me in the past with things we've done with Giant. Either we've done some webinars like this. We've written some pieces in Giant that have been placed in Giant's publication. We've done some presentations at TNC. So anyway, the reason I wanted to be on here today was to provide a little bit of continuity between things you've seen from us, Nokia, and things that you will see in the future. Roland, if you could step maybe to the next slide. And just a few pretty quick things here. First of all, we don't want to tell you what research and education purpose and goals are, or even the challenges, but we just want to acknowledge that we are certainly aware of them and how they differ from kind of some of our other customer sets. So we try to be pretty mindful of that as we put things together for you, as we engage with the different RD networks, and try to adapt how we the technologies we have and how we present them to you. So we go to the next slide. There's a fair amount of detail here, but what I wanted to do with this was just recognize these three general areas where we see research and education networks. By the way, not just certainly Giant or in Europe, but also across the globe. As we engage with them, we recognize that we know that you folks operate these large networks that are very much out on the cutting edge of technology, and that the fundamental purpose is for collaboration. So I look at these three categories and I think, okay, the first thing really is all about collaborative networks and how they get built and how we can help you utilize technologies like very advanced optical transport. And the shift today is into more of sort of the IP areas, which maybe have not heard a lot from us about in the past. So that goes into the second bucket here, which is when we talk about terabit networks and cloud interconnectivity. I'm not just thinking about very high speed data center interconnect, which we certainly have talked to you about in the past, but now we're expanding that a bit, as you'll see as Roland goes into his piece here, into areas where we're up on the OSI stack a little bit further, and we're talking about maybe some technologies you've not heard from us about in the past. And then, so that's kind of the terabit network and in cloud interconnectivity piece. And then the third part here that we want you to consider is security. We've offered you some materials and presentations and thoughts about layer one encryption and quantum safe key management in the very recent past. Now we want to, this afternoon, expand that conversation to include other areas of security, right? Because there's more than just securing data as it flies across the network, but there are other aspects, for example, DDoS, that we want to talk to about. So the next slide, Roland, please. So how does that really fit here? Now, I just want to acknowledge, if you will, a couple of technology areas that we've talked to you about in the past, and then give you a bit of I guess it's a preview or a segue into what Roland will talk about. Network complexity or scalability. These two things, from my view, by the way, my background is more at the optical layer, more at that kind of layer one foundational stuff. So I tend to view things through that lens. So a lot of what we've worked with you folks in the past has been things like our photonic service engine capabilities, the idea of using probabilistic constellation shaping to adapt the modulation techniques or modulation format that's on an optical link to very accurately match the noise characteristics of a channel. This is very layer one-ish sort of stuff. So this relates to, in my view, the scalability of the network. Are you really maximizing the amount of capacity out of a particular span, really trying to reach that Shannon limit? Those things are all still there, and you will hear more about that from us actually in the coming months. You'll see another generation of our PSE introduced to the market. But where we're at right now is our PSE 5. I don't mean as a promotional flag, but I'm just kind of, just sort of pinning where we're at now. We're operating around 90 gigabaud with this ability to tune that baud rate very finely to, again, adapt the performance characteristics to the noise characteristics of a particular optical span. So that's great. Again, that's all the kind of layer one stuff. We've skipping over the right a little bit into the security bucket, we've talked about encryption and quantum safe key management. Now again, we want to expand this conversation into other security areas. And then last but not least is this idea of automation, network automation. So, I hope, again, my comments here are just to, I hope, give you a little bit of continuity between what you've heard about from us in the past and what you'll hear about us, not just today, but in the future. We hope to do other sessions like this that provide even more detail into some specific technology areas. So let's see, with that, I think there's one or two comments I would make on the next slide, Roland, and then I'll give you the ball. But in terms of internet transit, this again is about, from my view, from my very layer one like view, optimizing that channel, that link performance to carry the best it can, but also about providing a lot of flexibility to be able to manage wavelengths in a way that allows for different institutions perhaps to share a particular facility. So a lot of flexibility and agility sort of concepts there. And again, the security on the other side. So with that, the concept here, by the way, is to, with this particular view, is to show these are just three areas, sort of services that we recognize that its member networks and other networks around the world in the research and education space, may be offering to their members. And just we're trying to highlight technologies that fit into those different service areas. So with that, I'm going to hand it to Roland and take it away.
Okay, thank you, Chris. So let's take it from the layer 1 up to the layer 3. Right? So the technologies that, now guys, if you have chat, if you have questions, I can't see them. I have here multiple screens that I'm looking at, so I can't, the multitasking thing goes a little bit beyond my capabilities. But as long as you can hear me and you can see the screens, that's fine. And we can take the questions at the end, right? So the technologies that I would like to discuss today is EVPN. So EVPN is today our common service layer for both service providers. Segment routing as our common transport layer. And FlexAlgo comes also into play there. As Chris indicated, we're going to talk specifically on the DDoS part of security, so protecting against DDoS attacks. We'll talk about the 800 gig interfaces, so there is more and more interest into going from 100 gig to 400 gig to 800 gig. And we'll talk about how all this IP and optical coordination is going to work in the future. I have one more thing at the end, sort of a surprise topic. And some freebies to give away to you. So if you manage to stay until the end, we'll talk about an additional fifth technology for you guys. So jumping in, EVPN. Chris mentioned automation as a big theme, and automation is easier if you have something simple to automate. Right? So we used to have basically for every service had their own protocols and their own way of working. And what happened with EVPN is it's an evolution of a VPLS service. So and they basically removed all the flooding of MAC addresses and they made it very much layer 3 VPN-like, using BGP to sort of not only share the MAC addresses and the IP addresses, right? So making EVPN sort of like similar to VPN services, using the well-known BGP protocol as a control protocol. So that simplifies life quite a bit. And we started EVPN, if I'm correct, I think it was way back in 2014, right? That was where we first had our initial EVPN tryouts in the Nokia SR service routers. When we started doing interop testing with the other vendors in the industry at ENTC, which is sort of our yearly event that where we showcase all the interop with the Junipers, the Huawei's, and the other colleagues. Around about 2018, it was that ENTC indicated that the whole EVPN feature was mature, right? Many service providers were using it. So the statistics you see, even that's the statistics from 2018, The quote is also coming from the ENTC report of 2018. So at those days, things were considered mature. That did stop us from testing it every year. So every year also the EVPN IETF guys came with new features. So when we had EVPN interrupt testing basically on the agenda of ENTC interrupt testing every year. Also this year and also for next year. What I've added something more recent, which is an article from DKIX. And I thought it was an interesting blog that was done by the CTO, indicating and showing a real example on how we used EVPN at this, what they call their Apollon platform. So for those not familiar with DKIX, DKIX is like the biggest internet exchange for sure in Europe and potentially also in the world. So they're using EVPN and a way to avoid all this let's say flooding of MAC addresses on their peering LANs, right? So I found it a very interesting topic and a very interesting written article from the CTO. Now, something else that is that's recently became very popular in the ENTC interrupt testing is segment routing. So segment routing is newer than EVPN. So EVPN is sort of like, okay, we've done that. It's there, it's stable. Everybody knows how to use it. We're all good. Segment routing is newer. It's a traffic engineering option. It's a sort of a way to avoid using the shortest path, right? So they sort of they use what's called segment IDs, and so these segment IDs indicate the path that traffic has to follow. The cool thing about the segment routing is that you get rid of a few protocols which service providers didn't really like. So the whole RSVP protocols, nobody really liked RSVP. So here again, we fall back on things that we know, on the classic IGP protocols. We have extended those a bit, and we have the option to indicate this famous segment ID or this identity that the path has to follow, either using an MPLS label or an IPv6 address, right? So these are the two options that we have today. Again, it's a way to simplify networks, and it's a way to make automation easier to do. Now, unlike EVPN, the segment routing is a bit more complicated. If you look at the, if you say, let's do a reality check, the two flavors of segment routing, the one using the MPLS label and the one using the IPv6 header. So it's SR MPLS or SR-v6. The SR MPLS is fairly standard, it's fairly mature. It's the SR-v6 which is still under standardization. We see limited deployment today, because the problem with the SR-v6 is that, and I'm not sure if I indicated it on the previous slide, but the SI, the segment ID in an MPLS deployment is 32-bit, while the segment ID in an IPv6, it's 128 bits, right? So it's way bigger than with the MPLS version of it. Now, the problem is that within IETF, they haven't been able to conclude. Right? So there are still the standards. So they had 3 different standards for segment routing. These days, they have 1 standard for segment routing or a draft for segment routing. But the problem is that it still has 2 options. So the SR MPLS is an option, the SR-v6 is an option. And what they are seeing is they need to compress this segment ID. Right, so the segment ID of the IPv6 address is something that requires compression. So, and this is currently under standardization, and hopefully we'll get to a conclusion very soon. If you're interested to read all about segment routing, one of my colleagues has published a book which is freely available. If you click on the link there, it's highly recommended for people who really want to know all the ins and outs of segment routing. Now, next to the 2 flavors, there is also something popping up, which is flex algo. So some service providers don't like the segment routing approach because, well, some operators, they don't like using central controllers, right? They have this network controller idea. They're very allergic to network controllers for whatever reason. Other operators, they have routers who cannot handle the complicated or the more potentially complex segment ID stacks, right? So they have, with FlexAllo, they found a new way of sort of extending the IGPs with not just a simple IGP metric, but with things like delay or cost, right? So then basically with the IGP, you can run multiple SFP algorithms based on different, let's say, characteristics. So this is an easy way to sort of find paths which are characteristic dependent. So the best, the shortest path, but then based on the delay parameters or the path based on the least cost. Right? So this is a bit of a, it can go as an alternative to segment routing, or you can actually combine it with segment routing. So these are sort of the popular things that are happening with the IP layer 3 protocols. The next topic I would like to touch is the topic of security. Chris mentioned it's a multi-layer approach, right? So I'm not going to say that what I will be talking about is all that we do on security. We have tons of activities ongoing in the multiple layers of our IP routers. It's a lot about testing software, it's the quality of the software, the security testing of the software, and so on. But what I would like to discuss today is really the aspect of DDoS, so the denial of service, because something very interesting happened, let's say mid last year. So mid last year, the DDoS attacks were mainly coming from botnets. And the reason being is that more and more IoT devices got infected with malware, and people are using those IoT devices to really launch very large scale attacks. Last year we had here in I'm actually based in Belgium, and we had a very big attack on the Belgian army, right? So I think they were out in May, around the May timeframe. They were out for a month or at least 2 weeks. So nobody in the Belgian army could update their Facebook profile or check YouTube for weeks, right? Now, very recently, I think it's a couple of weeks ago, there was also an attack on Fortnite, the game, and World of Warcraft, Call of Duty. All those servers were down, so that's probably even more concerning than the Belgian army being down, I guess. Now, the change, as I said last year, that started with these botnets, is that an attack launched from a botnet looks very much, it actually looks completely like normal traffic, right? So it's no longer some hacker generating some synthetic IP traffic. No, it's really fairly normal traffic, which is very hard to distinguish that traffic from any other traffic because it looks just like normal traffic. What we have also seen with these botnets and the way that the hacker community has been growing is that thanks to these infected botnets, the prices have gone down, right? The prices of attacks have gone down from $100 to basically as low as $20, right? So for $20, 20 euro, whatever, you can launch a botnet attack on your favorite website or your least favorite website. We even see gamers, just those gamers who are very eager to win a game, they actually launch those DDoS attack on their fellow gamers just so that they can actually definitely win the game. Also, the fact that there is something like Bitcoins makes it also much easier for people actually to get money, right? They no longer have to say, put the money on my bank account, which is a very dangerous thing to do, of course, if you're in the criminal world. So a lot of these things actually facilitate hackers to start attacking whoever they want. And obviously also the fact that we get more and more of these IoT devices connected to the internet using gigabit interfaces or 5G broadband also helps in creating more and bigger attacks. Now, as I said, the thing that has really changed is that the attack is exactly looking like normal traffic. So how do you differentiate the attack traffic from DDoS traffic. And this is where we have been creating a technology that is using AI and machine learning to sort of see patterns in what's happening on the internet. So we have a tool which sort of scans the whole internet, and it does it really continuously. So it's scanning the internet and it's checking who is on the internet. It's basically creating a sort of a database of bad things that are happening. And it's also creating a database of who is who on the internet. And it's actually combining this in a sort of a big data analytics to accurately detect DDoS traffic. So they will know that there are certain parking meters in Korea who are often used as malware, as start of a botnet, right? So when they see that IP address popping up, let's say here in Belgium with Proximus, they will say, that's suspicious traffic. And then they'll start looking, they will say, okay, that's suspicious traffic, so that's probably a DDoS attack. And when they detect that, they will actually instruct the routers, so they can give routers instructions to stop that DDoS traffic. So that means that rather than having some box inline which sort of suspect there is a peak of traffic and suspects that this traffic is problematic and tries to redirect the traffic to a scraping center, here the solution is actually immediately, when it detects the DDoS attack, it's immediately instructing the router to stop that traffic, which is a much less expensive way of providing a DDoS mitigation. Right? So that gives us a solution where we have the AI and machine learning detection in the cloud, triggering DDoS filters on the routers. Now, obviously, you need a router which is actually capable of doing all that filtering. So you need a router who is actually capable of.
Yeah.
I think Indrek should be on mute. So, and it's also specific. So the Nokia routers can actually do all that filtering. So we have like 100,000 of filter entries, and even if you would have all of them enabled, the wire speed performance of those routers is still wire speed. This is something that I hear from talking to service providers. I say, Roland, okay, I know we can filter on a router, but from our experiences, when we start having a lot of filters on the router, the performance of those routers goes down dramatically. Right? So, and this is for us the opportunity as Nokia. We say, okay, try it out in your network. See how filtering impacts Nokia routers, and you will see it has no impact at all. Right? So that's one part of the DDoS filtering that we do. So the AI combined with the DDoS filtering on the router. Another feature that we have is something which is called AnySec. So this is a proprietary Nokia features at the moment. So you need to be able to bookend the encrypted tunnel with 2 Nokia routers. And you should look at this as a sort of a MACsec, IPsec thing, but we can actually determine where to start the encryption. Right, so we can determine where in the OZ layer to start the encryption, basically. So we can say start the encryption, but leave the MPLS labels in the clear. So that means you can have a full LSP tunnel encrypted. So we see some service providers, operators, they're saying, okay, we want to sort of put traffic over the network, and we want to avoid, let's say, that certain traffic goes over certain routers, and that potentially could be considered a security risk. So they have this tunnel then going end to end from Nokia to Nokia using AnySec encryption to encrypt the traffic. Okay. Another, and Chris mentioned in the beginning, you have been discussing this, if you're very, very paranoia and you're concerned about quantum computers, we also have this quantum safe encryption at the layer 1. This is a thing that Chris talked about. This is at the optical layer. For instance, we have a service provider who is doing this for banks, right? So leaving the security topic and going to a little bit to the optical topic, these days there is a lot of talk. So simplification of the network with EVPN segment routing flex algo, that's one thing. Securing the network, protecting against DDoS is another topic. And then the third topic is really IP and optical convergence. Now, for those of you who have been in the industry for some time, we have created basically all kind of IP and optical convergence in the past. Many have not really been super successful. So the thing that happened sort of the last year is that the gray optics or the short reach optics and the coherent optics have basically become the same size, right? So very popular talking points these days are the 400 gig ZR optic pluggables, right? And even I've been listening to and talking to an analyst yesterday. They're already talking about 800 gig ZR optics becoming available in 2024, early 2024 is their estimate. So the density penalty that you used to have, right? The density penalty, if we go back here, the density penalty that you used to have by putting those coherent optics in the pluggables into the router is no longer there with the new form factor. And it basically allows some new ways of working. So here, the conventional IP network drawing that you see here, this is basically you will see most networks being run today, right? So they have a bunch of what's called short reach or gray optics connecting to a transponder, and from that transponder, it goes out with coherent optics, which are more complicated, or most of the time are more costly optics, and they go over the optical line system. Now, with these 400 gig ZR pluggables, you can actually get rid of the transponder. So that's where people are seeing the big benefits, cost saving, right? So you plug directly your router pluggables into the optical line system. Now, there are a number of, let's say, things to think about when you do this, right? So on one thing, it's the cooling, right? So there's a good thing and a bad thing. Let's say the positive aspect of the whole 800 gig ZR optics is that it gives you an additional, let's say, anything between 20 and 40% power savings, because a single 800 gig pluggable you consumes less power than two individual 400 gig pluggables, right? So it's an additional power saving that you get on top of the normal, let's say, for a router releases upgrades, of course, right? Now, what you need to be aware is that your router has to be able to cool those pluggables, because those pluggables are consuming 20 watt and more. And what we have done on our routers is actually what you can see here as this dual-sided PCB. So we have these, we have our line card. So if this is the line card of the router, so the line card you see here is in the middle, and we have pluggables on both sides, right? And we also have air intake on the top and air intake on the bottom. So we have designed the system in a way that you can actually cool those high power optics. Well, what we see with many other vendors is that they have this type of approach, so the stack gauges, where these optics are much worse at being cooled, right? So this makes that while we can put those pluggables in all our ports, we see that with other vendors, and that's something you need to be aware of. They can only put it in a limited number of ports, or when they put it in more ports, the fans have to run at full speed, right? So that's something to be aware of if you're checking out router vendors. Now, the interesting thing is the management of this type of configurations. So let's talk about what's called aliens, right? So when you initially look at optical networks, it used to be everything, the transponders as well as the line system, obviously the management system, was one single vendor. Then for all sorts of reasons, transponders were sort of disaggregated. So you got transponders from one vendor with an with a management system from another optical vendor, talking to the line system for vendor A. And so you had potentially two optical vendors in your network, and they call these optical connections alien wavelengths. You can see You can see the optical vendors were not a big fan of this type of approach because else they would not have called them alien, right? So it makes the whole end-to-end configuration of your network a little bit more complicated because now you have two management systems that you need to take care of. Now, what happened if we take then the routers into account? If you look at the routers, so we used to have these gray optics talking to the transponders and then talking to the optical line system. So that's all fine. There was very little coordination needed between the router team and the optical team. Now with the coherent optics, it's a bit of a different story. Now, you not only have two management systems potentially, but you also have two teams talking to each other. So now the IP team does need to talk to the optical team when they are configuring those coherent optics. So what we have done to facilitate the life of operators is building a system which is actually multi-layer or cross-domain, right? So our management system can do the configuration of the optical components in the router as well as the optical network. So it's one single management system who combines both, right? So that means that there is it's much easier for those different teams to actually work together. Now, and if this gives you a number of, let's say, advantages, because the whole optical layer is integrated with the IP layer from a management system. So if you're, this is actually a screenshot from that management system. So if you want to see, let's say, this IP service, which wavelengths is it using, or is this IP service really disjoint, right? Is it really following diverse optical paths? All that type of sort of back and forth connectivity is possible within your management system. And it really, because we have been presenting this business case to a number of analysts, and they have run their metrics, and they've been talking to different service providers using that type of coordinated control, and they came to amazing numbers of potentials of OPEX and CAPEX saving, right? So if you're interested in those studies, I will be happy to share. It's Apeldoorn Research who has done those studies. Now there is one more thing that I would like to say. I said I had a surprise or another topic that I wanted to share with you, and the topic is the data center world. So very recently, we have worked with, and I think it's 2 years ago, or it's probably, we started 4 years ago, but it's only 2 years ago that we launched the solution commercially, is a data center solution. So we had a talk with Apple, and the discussion was, okay, Mr. Apple, if you could think of the dream network operating system for your data center, what would the features be, right? What would be for you, let's say, the best network operating system for your data center? So we developed, together with them, we developed something which we have named SR Linux. So for those of you who are familiar with our service router from Nokia, there the operating system is called SROS. So this is a bit of a spin. So this is SR Linux. And this operating system, this network operating system is based on a standard Linux kernel, but it's from the ground up model driven, right? So it's the fact that we started with this very recently allowed us to really make use of all the latest and greatest technology that we know. The SR Linux also allows you to create a complete a digital twin of your data center. So service provider or data center operators can actually build the complete data center on a digital twin. They can try out the new features updates. They can try out software update. They can do whatever they want. And as soon as they are happy with the result, only then they need to push it to the real, let's say, to the real data center. Right? If you want to change the way that the CLI of this NOS works, you can completely tweak it. It's a Python based. You can completely write your own CLI. You can combine CLI commands, you can create aliases and whatnot. You can even, and that was something that Apple was quite keen on, you can create your own applications. Right? So you can develop your own applications, just provide the RPM with the Young model, load it on the system, and then the CLI or the API will be automatically extended with the new commands for your application. So I even, there are some basic Linux applications, or you can run on that data center. Whether it makes sense or not, it's another stuff, but it's completely tweakable, right? And that's the cool thing. If you want to try it out yourself, we have this tool, Container Lab. So if you follow the link which is here, you can download Container Lab. It's developed by a Nokia colleague of mine, but it's not an official Nokia software. It's community open source software, and it basically allows you to try out how this SR Linux works. Right. So if you use it, if you go to the web page, I can tell you, in 30 minutes you have a completely up and running data center. Right. It's super easy. It's no longer tweaking with VirtualBox and all those virtual machines and all that stuff. It's a fully container-based. It does not only run SR Linux OS, but you can also run the SR OS. So you can try out how it looks like if you want to build your own network, where you have a Nokia SR router talking to a Nokia SR Linux router. Or if you want, you can even take Arista images or Cisco images, whatnot. So it's not limited to a Nokia routers alone, right? And it's a good way to get a feeling of what SR Linux, or for that matter, what SROS, SRS can do for you. So no need to buy expensive hardware. Just run it from your laptop. Actually, I have it on my MacBook. So it's no heavy requirements, so you don't need super duper servers or tons of memory. Any laptop can run the solution. Now, this is a data center. So another big topic that we see popping up is the edge cloud. So the edge cloud is where a lot of people are seeing quite some commercial interest and new business cases. Putting all kind of new services. Let's say people are talking about mission critical enterprise applications and stuff like that. Those are going to be put on the edge cloud. Now the thing with the edge cloud is I cannot run a full-blown data center management system in those small edge clouds, right? Those edge clouds are really mini, but very mini data centers. So there we had to look at something different. We cannot just take the existing solutions that we have in the big data centers and put this in those edge clouds. So what we have done for the edge clouds is something a bit new. Right? So in the edge clouds, for those of you who are familiar, on those servers that are in the edge cloud, for sure there will be Kubernetes. So Kubernetes is like the container orchestration system. It's almost a de facto standard, right? So that's running there at those edge clouds. And then what we decided is like, say, okay, instead of building a completely new tool to configure the networking part at those edge clouds, let's just extend Kubernetes. So Kubernetes is designed to be extended, but it's not because not only us, Nokia, who has extended it. There's also many database vendors have extended Kubernetes for their specific needs. So we have extended Kubernetes with something which is called an edge network controller. And that edge network controller then automatically will extend also the APIs toward Kubernetes. So if you're running your Kubernetes GUI, you will see new commands, and these new commands will allow you to configure the routers in those edge clouds. So with this little extension, which is only using one virtual CPU, so it's very little CPU and power consumption, you basically extend the Kubernetes edge cloud with the networking capabilities. Now, also the cool thing of extending Kubernetes is that automatically, so you get all the complete ecosystem that comes with Kubernetes free of charge. So we have Elisa, for instance, in the Nordic, who is running this edge cloud with our edge network controller. And they are taking the data from their servers, from their routers in those edge clouds, and they're pushing this into the Google Cloud for analytics. So all these things come basically out of the box. Right? So this is a very cool development that we are seeing. And I'm curious to see how far this is going to go. So I think at the moment we have a couple of deployments, but I'm expecting that this is an interesting evolution going forward. And these things all combined, you will get like this. So we talked about the edge cloud, where we have this, our routers are in the edge cloud, and we have the edge network controller as set the extension of Kubernetes to manage those routers in the edge cloud. We have the data center fabric itself. So where we have developed as Nokia both the hardware, network operating system, and the management system on top of that. Actually, we have sold our hardware to Microsoft. So Microsoft was looking for data center hardware, and we sold them our hardware. So the difference, well, Microsoft obviously have their own network operating system, which is called Sonic. So they decided not to use the SR Linux operating system to run on our hardware, but obviously they decided to run the Sonic on our Nokia data center hardware. And then obviously, these are the first topics we talked about. We have the IP MPLS network with the EVPN, with the segment routing, with the Flex Algo, with the 800 gig. So our routers today have 800 gig interfaces with the IP and optical coordination to connect the edge cloud with the data center fabric. So and this is a bit the sort of a fast overview of what we have seen as hopefully of interest to you guys. And with that, I give it back to Chris for a summary. Chris?
Yeah, thanks, Roland. Great job. And let's see. Yeah, just a quick kind of summary of things is that, as I said earlier, we've provided a lot of thoughts and content in the past on the stuff on the right hand of the slide, the layer one technologies, and you saw also today, this afternoon, a little bit of continuing on that layer one theme. Maybe these things were or were not a surprise to you, but the coherent optic trend and development of not only 400 ZR but now 800 ZR optics, and a little bit of how those modules put together. It's really an interesting development. I did notice someone asked a question in there regarding where the future of that is. I'll take a stab at that right now just because I can't help myself. This notion of sort of eliminating transponders in some camps is viewed as a wonderful thing, right? And having direct connections from routing systems into the line system. Ultimately, you still need some form of line system out there. But I will say some operators, using that term very broadly, embrace this notion. Others are, as Roland said in a different context, allergic to it. So some people will still want some form of transponders there for various reasons, certainly for longer reach optics. And that just depends. So where do I see that going in the long term? I think it's true as we increase data rates, as we start to see, I don't know, a 1 terabit ZR pluggable optic maybe, or higher rates. We start to push against different design limits, perhaps in terms of heat in a small package. But this is like predicting the future. It's hard to say. In the real long term, do transponders disappear entirely? Maybe. It's hard to say. I mean, I've talked to people within our business group who say never. There'll always be those camps that need these transponders. And so I don't know, maybe it's not a very satisfactory answer, but I'm not going to say that transponders completely disappear. But I think, as Roland was showing you, there are advantages to using coherent optics and the pluggables in routing. So anyway, that said,
I think maybe Chris,
sure.
just to jump in on that part. I think if you're interested in, I think what I've found out that if you ask a vendor which only has routers, they will tell you the router is a solution for all your problems. If you ask a vendor who only has optical kits, he will tell you the optical kit is the solution for all your problems, right? So the cool thing, or at least what I think the good thing is of Nokia, is that we have both an IP and an optical product line, right? So we can advise our customer what makes sense for their network, right? Which I think is different from many other vendors who just have, if you only have a hammer, everything is a nail. And that's what they say. Right?
Yeah. Yeah, well said, right? And we try to avoid, you can't help it, but you try to avoid, you're calling my baby ugly, but this is the way technology evolves, right? There's no doubt it's a displacing technology, right? It's sort of a destructive thing in a way, but look at the advantages for some networks. If we're eliminating power consumption and space consumption, then that's helpful. Okay, so the other comment I wanted to make, and I know there's a few other questions in there, just things that I thought of while going through this. There's a number of topics here that are potential, areas we'd like to explore more with you folks, potentially other webinars like this. So the whole topic around DDoS and botnet-based DDoS attacks, interesting to me. I learned a few things there. I think this is stuff we'd like to explore more. The data center fabric and SR Linux topic, that's a good area where, we'll work with Carl, see if there's interest. We'd like to explore more opportunities to share our thoughts on these things. I did also want to mention before we conclude this, or we go into more questions, that we'll have a presence at the Supercomputing Conference next month, middle of November in Dallas, Texas. I suspect some of you folks may be over there for that. Feel free to engage with us. Roland, I don't know if you'll be there. I know I will. You certainly can come, Roland. As far as I'm concerned, be glad to have you. But
are you paying my hotel and my trip?
not personally, but
Okay.
But no, seriously, I know, especially in the R&E community, more than any other of our customer sets, I'm sure some of you will be there, much as when we go to TNC, we see people from North America there as well. And that's something I really enjoy about working in this space, by the way. So a few other questions there. I don't know, Carl, do you want to read those? Can you see those? Or
I can see